So friends, one topic that is important and I forget to cover it in the previous video or in the last video. So that is the time division multiplexing and that I will try to complete in this video. It would not be a long video. So like just like we have the frequency division multiplexing for continuous signal MT and we are already aware of it. We have time division multiplexing for digital domain, for digital signals. See. Up till now, what we have understood, suppose we have M1T, so this M1T is passed through a low pass filter and then it is given to like a sampler, and then the sampler creates the samples. These samples are quantized, and this after this quantized it is encoded, and then these bits are basically 0 1 0 1 1 0. This is bits are being transmitted. So if it is transmitted like through wire or through wireless. This is what we have done. So now let us stick to the wire transmission for the time being and understand why TDM is required. For example, let's say that there are three person P1, P2, and P3, and they want to make a communication with another person, say P4, P5, and P6. They want to send some sort of message or some communication is to be established between this. So one possible scenario is that there should be a dedicated channel for P1 between P1 and P2, P4. Similarly, there should be a dedicated channel between P2 and P5 and a dedicated channel between P5 and P6, sorry, P3 and P6. Therefore, if this is transmitting M1T, so they, after all this process, they can transmit it through one channel. After all this process, they can transmit it through this channel. M22 can be transmitted through this channel, and M3T will be transmitted over the dedicated channel. Now, suppose if P1 wants to communicate with P6, in that case, again, there need to be a dedicated channel but between P1 and P6 for the message to be transmitted from P1 to P6. But actually, there is not so much dedicated channels. But in practical scenario, what actually happens, it's like, first of all, so much of cable laying is not possible. Every one person is connected with every other person with a single dedicated cable or a single dedicated channel is not possible, not feasible also. So practically what happens is like, suppose these three persons, there is a central hub. They send their messages to here, all these three, and then there is a single dedicated channel between another central hub, and then all these messages are being sent through a single channel or a single cable, and then here is another separation of all these messages is taking place, and now which message is dedicated to which person, it is being handed over to that particular person. So this is the case. So what actually time division multiplexing is doing, suppose this P1 is having M1T message, this is having M2T message, this is having M3T message. So all these messages are sampled here, encoded here, sampled here, quantized here, encoded here, and then transmitted here. Bits, all the bits are transmitted over. Then all the bits are received over here, then all the reverse process are done. Decoding is done, then again passing with the low pass filter, each sample is passed through the low pass filter, and then the message signals are generated. Okay. So for single message M1T, like suppose this is a single message M1T, after passing through the low pass filter, we are having that there is a sampler. And if this is FM, so the sampler is sampling at what rate? It is sampling at twice of FM, which is nothing but FS. And we have seen in case of PCM that the sampling time interval TS must be equal to N into TB. This is what we have seen in the PCM. That means that by the time the one sample is sent, it must be encoded in N bit and all the bits should be transmitted. So if one bit's time duration is TB, the N bit duration will be NTB, and this must be equal to the sampling interval TS. Okay, that's it. That is the recapitulation, or we can say the PCM technique. Correct. So here we should have something that should like at least do the sampling in such manner. At least do the sampling in such manner. So this device is known as the commutator. So here we are having one commutator. This is the commutator. Okay. It is rotating in anti-clockwise direction. This is the commutator. Then instead of sampler, what we have? Commutator. So after commutator, what we are getting? We are getting samples. But here, these samples are not from a single message, but multiple message. Let's say suppose this M1T is given over here, M2T is given over here, and M3T is given from this side. Okay. So these samples that this commutator is generating, these all samples are basically samples of what? M1T, M2T, and M3T. Just understand that suppose this is a restaurant hall. There are three tables, table number 3, table number 2, table number 1, and there is only one waiter who need to serve all these three tables. So he will go each table turn wise. First of all, say suppose he went to table number 1, then he went to table number 2. Okay, from 1 at time t not he went to 1. At time t2 he went to t1 he went to table number 2. At time t2 he went to table number 3, and accordingly he will come back to table number 2 if any service is required. Accordingly he will go. This same technique is used in TDM. Now, commutator what has to sampler what it did, it ensured that the sampling is done at the sampling rate fs, which is nothing but twice of fm. This is the Nyquist rate. So commutator also has to do that same thing. It has to sample m1t after each ts. What is ts? Ts is nothing but the sampling interval of m1t. So after each ts, it should come back and collect one sample. After again each ts, it should come back and collect one sample. So since let us assume that M1, M2, and M3 have same bandwidth FM, so we can say that Fs will be equal to twice of FM, or Ts will be equal to what? Ts will be equal to 0.5 EM. That is, we have seen in the pulse code modulation. So try to understand that this commutator is rotating such that it takes one sample and exactly after TS interval, sampling interval, it collects another sample. Exactly after TS interval, it is collecting another sample. So suppose it starts with time T0. So second sample will be collected as T0 plus TS. Third sample will be collected as T0 plus 2TS. Okay. Similarly for message signal 2, this, so from here, before going to the message signal 2, from here, can we say that the rotation speed of this commutator, should be such that it complete one cycle, one complete cycle, like starting from here, it collects one sample and then rotates and collect all samples, all other signal, and then reach back to this point to collect another sample exactly after Ts time interval. So can we say that the rotation speed is equal to, that is one complete cycle, time taken for one complete cycle, that is Ts. We can say that, or this Ts can also be known as the frame timing or rotation timing. Whatever you wish to say, you can say rotation timing. This Ts is the rotation timing. So for this signal, obviously if starting at t equal to t0, so this may be sometime t0 plus 1, suppose t1. This timing when the first sample of this m2t is taken is t1. The first sample of m0, m1t is taken at time interval t0. So if this T1, then another sample will be taken as T1 plus S. Another sample will be taken at T1 plus 2S. So each signal, similarly, suppose first sample is taken at the time T2, then after every TS, it will take another sample. So each signal is now sampled by this commutator, and also it is ensured that the sampling interval remains that of the Nyquist rate TS. अगर इतना समझ गए, if this is clear to you, then can we say that earlier when we wrote that Ts is equal to n into Eb, in this case, when we have multiple samples, So each samples, how many samples would be there? Like in one rotation, how many samples it will collect? It will collect one sample, two sample, three sample. Jitne messages hai, the number of messages that are input to the commutator, that many samples it will collect. So in one rotation period, it will collect how many samples? N samples, where N is the number of messages. Okay. Here in case we have three. It will collect three sample. Okay. So in TS time period, it will collect three sample. All suppose these were the three samples. Now all these three samples, like previously we have done, previously in TS it was collecting only one sample. Okay. Previously in TS it was only collecting one sample. But now instead of one sample, it is collecting how many samples? Three samples. And one sample was to be sent, and we can say was to be encoded, first quantized, then encoded with n bits. So we can say that it was requiring n TB time. So here also, if three are there, if three samples are quantized in same time interval TS, so each samples will be now encoded. Suppose if n bit encoder is there, so what would be the total number of bits for three samples? It would be 3 into n bits. This will be the total bits. Earlier only one sample was there, so we have n bit. Now we have sampling we have samples of three message signal. So three message signals are producing how many samples? Three samples. So 3 into n bits. Okay. Now timing of one bit is TB. So here the timing will be 3 into TB. So in the same time interval TS, how many bits we are sending? We are sending 3 into n bits, and the timing of each bit is TB. So generalizing this, we can write TS is nothing but capital N, that is number of messages, into N, that is number of bit per message, multiplied by TB. This is the important formula with respect to time division multiplexing. Okay, it's if you're not understanding, just rewind and listen to what I am saying. Okay, you will be able to understand. Now, okay, this sampling is done, encoding is done, it is given back, and there is another commutator that is known as decommutator. So that has to be also sampled, the sampled all the signals that is coming to it for at the receiver end. So this commutator and decommutator must rotate at the same speed, that is TS. So how does this decommutator knows that whether this total number of bits that are coming, that is 0001, whatever bits are coming, is complete, or it has to sample exactly that number of bits. For example, here we are having 6 bits. So how does the commutator know that after exactly 6 bit, I have to complete one complete rotation? How does it know? So for that, we have a synchronization bit extra mechanism, which is known as the synchronization bits mechanism. Synchronization bit mechanism. So with the total bits, we send some synchronization bits. So what were the total bits that were sent? Total number of messages, number of bits per sample. Now, with this, we will add the synchronization bits. This was the total bits that is now being sent to synchronize the commutator, multiplied by the timing of one bit. This should be the total time of one frame. One frame time, or we can say that the sampling time. So this is another important formula that you should remember. Just in this total bit, we have added here the synchronization bit. Remaining thing is same. This is one formula. This is second form. Okay, that has to be remembered. And remember, TS can be always substituted as 1 upon Fs, and TB can always be substituted as 1 upon RB. So RB is known as the bit rate, and Fs is known as the sampling rate. Okay, now if that is clear, and since we have talked about synchronization, so let us understand one more thing. Now suppose I have allotted M1T, M2T, and M3T, and we have assumed that each are having the bandwidth FM. Now suppose such may be the case where after certain time interval, M1T is there, M2T is there, but M3T is not there. Even though MT3 is not there, it will look for the sample from M3T. Just understand that thing. Even though M3 or person 3 has nothing to send, this commutator will still be looking for their messages at this point. So in such scenario, this is known as the synchronized TDM. What is synchronized TDM? In which each message is allotted a fixed time. allotted a fixed time. That is, even though at on that time, suppose it is 1 second, 2 second, 3 second, even at 3 second, after every 3 second, there is nothing to collect from here, but the commutator will try to collect. This is called fixed timing, and this technique is known as synchronized TDM. What is asynchronous TDM? Asynchronous TDM. In asynchronous TDM, the time slot to the messages will be allotted dynamically. Okay, this is the difference between synchronized TDM and asynchronous TDM. Now, till now we have assumed that this is M1T. Let us restrict us to the only two messages. This is M1T and this is M2T, and this is being given to a commutator. Okay, rest all the means block, that is the pointizer, encoder, anything. And obviously there is LPF is there. LPF is there. We have discussed all this block element previous videos. So you can go and check out if you are watching this video directly. So the M1T, and we have assumed that M1T and F2T are M12T and M2T are of the same bandwidth. Now, what if these are two of different bandwidth? This is 1 kilohertz, this is 2 kilohertz, and this is the commutator. Previously, we know that both the message signals were of same bandwidth. So therefore, sampling rate जो है वो दोनों सिग्नल के लिए सेम था. So हमने इसका टाइम सेट कर दिया कि भाई after that particular time interval you have to collect sample for each message. But now what would be the sampling rate or what would be the rotation time? Yes, rotation time क्या set करें? So always remember कि each message signal MT should only be sampled at Nyquist rate. अगर Nyquist rate से ज्यादा करेंगे तो कोई इशू नहीं है, लेकिन आप क्या होगा, बैंडविड्थ आपका बहुत ज्यादा यूज है ना, बैंडविड्थ बहुत ज्यादा बढ़ जाएगा, बहुत ज्यादा सैंपल्स होंगे. ऑब्वियसली Nyquist rate is Nyquist rate जो है FS is वही sufficiently large है, twice of FM. अगर आप उससे भी ज्यादा करने की कोशिश करोगे then you will end up in large many numbers of samples. ठीक है, so we always ensure in TDM कि message are always sampled only at the Nyquist rate, that is twice of FM, not more than that. तो अगर मैं इसको 1 किलोहर्ट्ज रखूं तो मेरा Nyquist rate क्या हो जाएगा, twice of FM यानी कि 2 किलोहर्ट्ज. और इसको मैं अगर टाइम में कन्वर्ट कर दूं 1/2 into 10⁻³ that is 0.5 मिलीसेकंड. तो अगर मैं हर 0.5 मिलीसेकंड पे सैंपल कलेक्ट करूं तो ये तो अपना Nyquist rate पे आएगा, लेकिन इसका भी सैंपल कितने पे आएगा, 0.5 मिलीसेकंड पे आएगा. लेकिन इसका क्या होगा, 0.25 मिलीसेकंड पे हमको कलेक्ट करना चाहिए. ओके, क्योंकि इसका Nyquist rate M2T का Nyquist rate क्या होगा, 4 किलोहर्ट्ज होगा, है ना, क्योंकि बैंडविड्थ 2 किलोहर्ट्ज, तो ट्वाइस ऑफ दैट 4 किलोहर्ट्ज. सो this has to be sampled at every 1/4 into 10⁻³ that is 0.25 millisecond. But here what we are doing, if we fix the message signal at 1 kilohertz and we take this as the sampling rate, so it is sampling after each 0.5 millisecond. So that this sample is like this message signal is sampled at the Nyquist rate, means at a rate which is less than the Nyquist rate. Means we are sampling it at what rate? We are sampling it at 2 kilohertz. That is why it is collecting sample after every 0.5 millisecond. But ideally it should be collected sample at what? 4 kilohertz. And we have restricted ourselves that we cannot go beyond 2 kilohertz because M1T का जो Nyquist rate है, that is only 2 kilohertz. So in that case, what we do, we will sample this twice. We will again connect one message, this M2T. तो M2T को हम twice कनेक्ट कर देंगे. तो अगर ये मेरा सपोज करो M1T है, ये आपका कितने पे हर्ट्ज हो रहा है, 1 किलोहर्ट्ज पे हो रहा है. तो M2T को हम, ये 2 किलोहर्ट्ज का मैसेज है, इसको हम 2 बार कनेक्ट कर देंगे. तो 2 बार कनेक्ट करने से क्या होगा कि the message signal is now sampled with the minimum Nyquist rate. Okay, so that the bandwidth is also minimum. तो ये सिग्नल को अभी हम 2 किलोहर्ट्ज में हम कर रहे थे, तो ये 0.5 मिलीसेकंड पे एक बार सैंपल कलेक्ट करेगा, इसका भी 0.5 मिलीसेकंड में 2 सैंपल कलेक्ट करेगा. 0.5 मिलीसेकंड पे 2 सैंपल्स कलेक्ट करेगा सेम मैसेजेस के. एक सैंपल यहाँ से कलेक्ट करेगा और एक सैंपल यहाँ से कलेक्ट करेगा. तो 0.5 मिली सेकेंड के इंटरवल में ये दो सैंपल्स कलेक्ट करेगा। इसका मतलब क्या हो गया कि एक सैंपल का इंटरवल कितना हो गया, 0.25 मिली सेकेंड हो गया, यानी कि इट फॉलोज द नाइक्विस्ट स्ट्रेट। So this is the technique that we do. If there are different messages of different bandwidth, so we try to connect them parallelly to the commutator so that each sample gets sampled at the Nyquist rate of the minimum bandwidth sample. Nyquist rate ये sample decide कर देगा, ठीक है। चलो एक क्वेश्चन करते हैं, so we will better understand this. Suppose if we are having four messages, G1T, G2T, G3T and G4T. ये फोर मैसेज सिग्नल्स है। अज्यूम करो कि G1T को बैंडविड्थ है 4 किलोहर्ट्ज मैसेज का, और G3 का बैंडविड्थ है 4 किलोहर्ट्ज, और G2 का 8 किलोहर्ट्ज है, और G4 का 8 किलोहर्ट्ज है। अब इन सारे सिग्नल्स को हम कम्यूटेटर के पास देते हैं, और इनकोडर हमारे पास कितना है, 8 बिट का इनकोडर, 8 बिट इनकोडर। तो ऑब्वियसली वी हैव गॉट n इज इक्वल टू 8। तो अगर हमें फाइंड करना है कि व्हाट इज द बिट रेट, व्हाट इज द वैल्यू ऑफ आरबी, हाउ वी विल प्रोसीड दैट। The lowest frequency is what? 4 kilohertz. That means what would be the FS? FS would be like 8 kilohertz. Correct? Twice of 4 kilohertz, that is 8 kilohertz. And this is 8 kilohertz signal. So this has to be connected twice. Actually, this has to be sampled at what? 16 kilohertz. But actually, we are fixing the sampling at 8 kilohertz. So this 8 kilohertz and this 8 kilohertz has to be sampled twice. So how many signals we will have in real? One. This will be like two signals from here. It will be connected twice so that the samples are collected at the Nyquist rate. This is one signal over here, and this 8 kilohertz will be again connected twice. So total signal will be 1, 3, 4, 6. 6. So capital N is equal to 6. So we have capital N is equal to 6 and N is equal to 8. And we have to find minimum RB. Okay. So what is TS? The frame timing is such that it send all the bits. Total number of bits is n into n, and let PB be the bits timing. Here we are neglecting A because in order to find the minimum bandwidth or minimum bit rate, this A is taken as 0. Synchronization is taken as 0 until specifically mentioned. So this is nothing but 1 upon Fs is equal to capital N into small l into 1 upon Rb. Or from here we get Rb is nothing but capital N is what? 6. Small n is what? 8. It is 8. And what is Fs? Fs is nothing but 8 kilohertz. So this is nothing but 6 into 8 into 8 kilohertz. Whatever you get is the answer. Most probably 64 into 8, that is 384 kilohertz. So guys, with this now we are ending this communication topic. Communication topic is finished. At the end, like suppose in the last week or so, I'll be sharing if there is another any other topic that has to be discussed, I will be updating another video on that. But as of now, we will consider the communication as completed. There are topics such as the entropy and random signals, random that is messages, and then we have the noises, channel noise, all that thing that we are not going to do because I don't think that is that much important from this examination point of view. So here we are ending with the communication, and from tomorrow on we will move on to the next topic as per the schedule. So thank you very much for watching.